Cool. All right. So, hi everyone. Yeah, first I just wanted to thank Mathieu and Andy and Potluck for hosting. I actually used to come to Ruby, Montreal.rb all the time back in 2007, 2008, and it's my first time coming back. Tells a bit about my age too. So I'm very glad to see that Ruby is still alive in Montreal.
That's
and
when Mark was
trying
presenting the PIN server.
Yeah, exactly. Yeah, around those years. Cool. So that's me. So I'm the co-founder and CTO of Circle Medical. Been doing Ruby for a long time, 2005. I'm from Montreal, but I've been an expat in San Francisco since 2011. But most of my family are here, so I come back regularly. So what Circle Medical does is like pretty important context for what I'm going to talk about tonight, which is an AI Medical Scribe. So I'm going to start by giving a little bit of context and the problems we've been facing and why we went on that journey. So Circle Medical, we're building the technology to make delightful, quality primary care accessible to everyone. The thesis of Circle Medical starts from the iron triangle of healthcare, which in traditional healthcare says that quality, cost, and access are an indivisible trade-off. So if you want better quality, you need to increase cost or lower access. If you want a lower cost, you need to lower access and quality, and so on. And we fundamentally believe that technology can break that iron triangle of healthcare. So we've been working on this for 8 years. So it's been quite a journey. We started
I just thought it was very interesting that the triangle is very similar to the triangle of software engineering with costs, scope, and time.
Yeah, similar. So yeah, we started with that belief that we could break that triangle using technology. And we started Circle Medical in San Francisco back in 2015. We went through Y Combinator. And during the pandemic, a big shift happened where a wave of telehealth came, and telehealth became accepted with doctors as well as payers, so insurance companies. And we've been really riding that wave since then. Today, we're seeing more than 50,000 patients per month. 97% of them are virtual. We do have 23 physical clinics across the US where we see patients in person, but it's a very small percentage. And then we have headquarters in San Francisco and in Montreal. Our team is about 25 engineers, and we have like a pretty bland Ruby on Rails stack with React, Next.js, and we're building native app for the patients as well. So why did we went on the journey to start building an AI scribe? So first, there's two big problems that have been around for a very long time in the medical field. The first one is what is often referred to as pajama time. So it's the time that doctors spend documenting their visits, sending orders at the end of the day after they're done seeing their patients. And there's some statistics that in the US, doctors spend on average 2 to 3 hours at night finishing their notes. And that is in part responsible for some of the burnout. Like in 2022, 63% of physicians reported that they were experiencing some kind of symptoms of burnout. So we put a lot of administrative work on physicians when they should spend their time taking care of their patients. And then the second problem is a problem we started experiencing as we've been growing. So the documentation is very important for many reasons. First, for patient education. So what goes in the note, part of it is the plan for the patient that goes to the patient. The clinical note exists for legal and compliance, like doctors to cover their butt, essentially. It's important for continuity of care. So if I see a patient and then I refer you to somewhere else, the other doctors needs to have the story of the patients. It's also important for billing, especially in the US. Everything, all the billing is done around what's have been documented in the clinical note, and it really impacts how much you're reimbursed. So as we've been growing the number of providers, today we're past 350 doctors. It's been really hard to keep the quality for all those things consistent across all providers. So possible solution, a scribe that listens to the patient-provider conversation and writes the documentation for you. It's actually not a new idea. There are services where you can hire a human that sits next to the doctor and then will type and document. It's just very expensive when you need to have a human. It's also a little odd to have like a third person when you're talking with your doctor. And it's also very like imperfect. So when LLMs came around, it seemed really like a game changer to be able to solve that problem with technology. At least three reasons. First, LLMs are really good at some NLP tasks like summarization and text generation. So taking a conversation, summarizing it, and then generating a clinical note in a certain format. The GPT has actually been trained on clinical notes. You can tell by prompting. I don't know whose medical records, but it's definitely been trained on medical records. It also has a lot of medical knowledge, which help actually being like accurate and good in what it suggests. GPT-4, just without any specialization at all, has exceeded the passing score for the U.S. medical licensing exam by 20 points. So it would pass the medical exam with pretty good grades. And then why Ruby? We're stacking Ruby. We love Ruby. I love Ruby. And then I believe that AI and machine learning is now actually accessible to every developers. It should be in all developers' toolbox. It's not just for data scientists anymore. Like those things are easy to use. So you'll see later tonight. Then the tooling in Ruby is pretty good. Thanks to some like really dedicated contributor like Andrew Kane. But like most of the tools are existing already out there or have binding to machine learning tools that are used in the industry. Then why did we decide to build this in-house instead of buying it? Because there's like tons of startup doing AI scribes today. It turns out that the LLM is what really does like most of the heavy lifting. Building it allows like really provide a superior experience to the doctor by being able to integrate it into or EMR. And then we also have the data and we have the feedback loop with doctor to get feedback. So that's actually where it really helps to build a better product. And then we also wanted to develop some of the expertise in-house because we think LLMs can be applied to a lot of other problems in primary care. So with the context, here's our roadmap for tonight. So I'm going to take you a little bit on the journey we've been and go through some of the challenges we've encountered as we've done this, and hopefully share some insights that can be useful and inspire you with some of your other projects that would use LLMs. So first, the first step is capturing transcript. So you have a patient-doctor conversation. So in our case, in most of the time, 97% of the time, it happens in a video call between the provider and the patient. And the starting point is we need a transcript from that conversation. So there's a lot of ways you can accomplish that with different pros and cons. So I'm going to just quickly go through each of the options with what we found with some of the pros and cons. So the first option is just to integrate with your video call vendor API. So tons of vendor already have transcript built in, like Zoom, Google Meet. We almost started earlier. DailyCo is a big one as well. And that's like very easy to get a transcript from there. It's just typically you change a setting and you use their API to access. So it's getting it in our case from Zoom is 4 lines of code is essentially to get a transcript back at the end of the visit. So it's really easy to integrate. The experience is seamless for everyone because it can already capture the audio. The cons is the quality of the transcript can vary depending on the vendor you use. You don't have a lot of options. You just take what they have. And then the ability to have a real-time transcript can also vary. So you might only get the transcript at the end of the call. Another option is that you have a bot that joins a video call. If you go on sales calls, you may have seen that. All sales team now have some kind of note-taking bot. So that's nice because it works across a lot of different vendors. You typically can get a real-time transcript. If you are in a patient-provider call, it's a bit odd to have like a third person, which is a script bot in this stream. I mean, it's not the end of the world, but it's a little odd. If you want to build that yourself, it's like pretty involved. But there are third party that you can use, like Recall.ai is an example that just like have a very, very simple API to do this. That's something we couldn't use in healthcare because they don't have the compliance. It's still a small startup. Then another route is building a desktop app, which is obviously like a pretty involved project. So it's nice because it works with all the video apps. It works on the desktop client also. Like today, by default, or doctor use a Zoom client. It's a seamless experience for the patients, but obviously developing and maintaining a desktop app is a lot of work, especially when you need to support multiple OS. And then finally, a web app in option or a Chrome extension, kind of go in the same category here, is possible and fairly easy to build. There's tons of third-party vendors that does transcription today, so you have a very wide choice of options. There's even like medical specific ones and some for other industry as well, so you can get really good transcription, and it's fairly easy to integrate. It works only when the video call is in the browsers, which is a limitation, but not the end of the world. And then the UX is also a little clunky when you want to capture the audio in the video call and the audio of the person talking. So they all have trade-offs. So on our end, we decided to go with getting the transcript directly from our vendor, Zoom, and we're probably going to go towards a web-based solution eventually to be able to get better transcriptions. So what are the common issue with transcripts? Omissions, so sometimes it misses things. Names can be challenging. So for us, the name of medications was like if you don't have a medical-based transcriber, it just doesn't get them. Medical conditions, pharmacy names can be challenging. Date and times also are sometimes a little tricky. So originally we spent some time like looking at transcript, and then we ask ourselves like, how accurate does the transcription actually needs to be? And it turns out that it was a lot less than we thought. Like even medication names that are not picked up, that is just like written in the sounding word, but it's not the actual correct name. The LLM would correct them once we send them to the LLM. So it corrected a lot of errors based on the context. So that was for transcription. Our second step is the identification of the transcript. So why de-identify the transcript? I mean, some of it is a little obvious, but privacy and compliance in healthcare, some people are a little, with some reason, be spooked out that we would send such like sensitive information as their conversation between the doctor and themselves somewhere else. Also, it's important to mention that the identifying is not a replacement to have an AI stack that is secure and compliant. It's not, the identification is not perfect. And then if you're starting to fine tune the model and train the model, then that's even more critical because some of the data you feed to the model could be exposed, or you may become vulnerable to some attacks. So the identification solution, there's like tons of options out there. Like some it's built in the video call solution, like Amazon Transcribe is an example, Assembly AI as well, where you can just ask with an option to get a de-identify transcripts. So that's very easy. There's some also de-identification dedicated services. From what I hear, the leader solution is private AI, which just does that in a very high accuracy, and we were able to configure very detailed what you want the identify. And then there's also a bunch of like open source solution if you prefer to do it yourself. Yeah.
I'm curious, what is the identification exactly? Is it simply like eliminating words that can identify the person that was recorded, or is it something else?
It's I have an example here. So obviously like all the demographics and things like that, and then you could also like here we're not identifying medical conditions, but you could do that also. You could just say like remove all medical conditions. So that's an example of private AI, which like you can go online and try their product. So you can actually configure what you want to identify, de-identify. And in healthcare in the US, there's like a very clear like guideline as part of the privacy. There's like, I think it's 18 like elements, pieces of information that you need to remove in order for it to be considered de-identified.
So it's basically from what we're seeing here, it's the name, the gender, the age, the location.
Yeah, you could have phone numbers, credit cards, like there's a bunch of other things you can.
Does this affect like the recommendations? You know, like for example, age and gender, those could be things that are important. Healthcare. Does that affect?
It could, yeah,
It could.
yeah, it could. So that was the identification. So third step, actually generating the clinical note or writing the clinical documentation. So I'm going to take you a little bit through like a few iterations. Like in practice, we did a lot more iterations. It's a little bit more involved than this, but I'll try to keep it simple. But the baseline was just asking GPT-4, can you generate a clinical note using this transcript, like a very, very simple prompt, as you can see. And we asked to use the SOAP format, which is it's not the same format as you guys would expect. It's the format that the doctor use, that is the most used to document visits. And I have an example here. It stands for subjective, objective, assessment, and plan. So it's a standard way to document a visit for doctors. Yeah.
So it's not SOAP API.
Exactly. It's not a SOAP XML API. So yeah, here's an example. So the simple prompt, just dump the transcript that we capture, and it will like generate like a fairly reasonable clinical note in most cases, which with like 5 minutes of work is pretty impressive. And then there is I mean, it's a good baseline, but there are a bunch of issues so as we dig a little bit more. So the first one is hallucinations. So it makes stuff up, which is not really good in healthcare. Then
Doctor can cure it, though.
yeah. Then the output can be very inconsistent, like the way it will write the plan, like the tone, can be very inconsistent. And then we don't know what like really best practice it uses, because we don't really know on what it was trained, but it doesn't use our clinical best practice. We have a clinical team that spends a lot of time to determine, like, for this condition, that's what the things we should do, that's what we should tell the patient. And out of the box, it obviously doesn't do that. So one example of association that's more kind of a funny example, but so we had generated that for trying from a conversation, and it was saying that the patient is a 30-year-old male, in like right the first sentence in the subjective part, but nowhere in the transcript it was talking about the age of the patient or the gender. So just ask, how do you know that the patient's age is 30 years old? And then it responds, I apologize for the confusion. The patient is not mentioned in the transcript. The age of 30 years old was an assumption I made in the previous responses, which was incorrect. In a real life scenario, the patient's age would be an important piece of information to gather during the initial history taking. So, I mean, it's funny, it's kind of obvious, but it's a real problem. So yeah, what are some of the things we can do to reduce hallucination? There's more, but I'll keep it to the obvious ones. But be explicit about not making stuff up. And then we found that giving the LLM more context, especially like the obvious context, was also really helping. So I mean, that seemed kind of obvious, but like here we just started with the prompt with, "You're a very accurate professional medical scribe," and then tell it to not make any recommendations that were not explicitly mentioned in the transcript, and that solves a lot of those issues, like we just saw of the age. And then the second thing is give it additional context. So, I mean, there's a lot of things we already know in the medical chart. And instead of having GPT trying to guess it or make deduction from the transcript, which sometimes is not complete, we're like, why don't we just like give it the context? So an example would be saying that it's a 26-year-old male here for what type of visits, or for an ADHD follow-up. So that gives more context. And then we can go further, also include things like the patient's problem list, include the patient's active medication list, and so on. And that really helps the LLM make less deduction and less errors. Issue number 2, inconsistencies. So that's an example of like 2 versions of the same plan, like written differently, and the LM might return either of those. One is just talking like as an observer. So the provider will send a refill of 60 total tablets, while the other one is from the perspective of the provider. So I will send you a refill of 60 total tablets. And obviously, when we have things that are generated that will be sent to the patient, we want to be really consistent about how we address the patient and the tone. And again, I mean, similarly, it's like about being really explicit, and it solved a lot of those issues. So being specific about telling what kind of tone we want and how to address the patient. Issue number 3 is a bit more tricky, but it doesn't, out of the box, it doesn't use or clinical guidelines. And as I said, we have a team of doctors who spend a lot of time determining or clinical guidelines. So here it came up with like a very simple plan. But when we look at what we would do, we actually have called them macros, but they're like templates essentially of that help the doctors write what is needed in the plan. So doctors like do that, use those macros and those templates to help them like think about what needs to be in the documentation, as well as like writing it faster because you have some of the text that is already filled out. And our clinical team spent a lot of time putting those together. We have over 700 of them for like all the different medical conditions. So how can we have the scribe use them? So I know last month talk was about the RAG approach. So like you create embeddings for your knowledge, you put this in the vector database, and then you query. We tried that, but it wasn't really working well at all for this problem. So we took a slightly like different approach. Like at the end of the day, what you want is give the AI the right context. So what we did is first we created a dictionary of our templates. So we actually used the LLM to create a description of the template. So we only had originally the name and the full template, and that's not really useful. So we generated description automatically using the LLM. And then we use the LLM to pick the appropriate template based on the conversation and the context of the patient chart. And that did pretty well. And then we expanded our little prompt here and added the template as context when generating the clinical note. And that worked pretty well. So then the fourth step, so evaluate and iterate. So we saw that we went through some iterations there, but a lot of different iterations. And every time you change something, like you don't know if you broke something else. So how do you actually know that you're making progress? And then how do you make a lot of experiments and iterate quickly? So traditional machine learning has like very like hard metric, your precision recall, the area under the curve, and you can know if you're making progress or not. With text that you generate, it's a little more tricky to know that you're actually making progress. So there's at least 3 strategies that we looked at to do that. So the first one is like pretty obvious, but human feedback. So building feedback into the feature. So we generate that suggestions for the doctor, and the doctor actually like read it and review it and can tell us if it was good or bad and what was wrong with it. So getting like obviously human feedback is great. It's really great feedback. But it has one big caveat, is that it's very slow to iterate, and it can be really costly as well. We did it as part of like real encounters, so it didn't take a lot more time. But then you can't test like 10 things at the same time, or run kind of like regression testing on like things that you change. So it's can be challenging. Another option is compare to the ground truth. So the ground truth meaning that you have a clinical note that you know is good, and that you can compare what you're generating with the LLM with that. So there's a bunch of different metrics that exist out there to do exactly that, and basically it tries to determine the similarity of like facts within the text. Um, so so here at the bottom there's a paper that actually looked at like all those different metrics and also a human expert, and they found that blurred, so the fourth one was the one where there was the closest correlation between the blurred score and actual doctors reviewing the notes. So what blur does is, yeah, basically take as an input a reference, so the ground truth, and a candidate, so the thing you're testing, and then it returns a score that that indicates like how much like the two mean the same, basically. And it's a trained metric, so it's actually like a machine learning that has been modeled to do that. And then there's an example at the bottom of something that means about the same thing, but written in different ways, and it tries to tell you how close they are to each other. Finally, the third strategy is creating a grading criteria prompt. So using the LLM to grade your result. So you can similarly, like we designed a prompt to generate a note with specific instruction. You can kind of do the same thing with an evaluation criteria. So, so like coming up with a score, like it's a 100-point score, and then 5% is for getting the tone of the plan right, or you're talking to the second person, to the patients, and then you are looking at a like hard number and can see if you like majorly broke something or not. Cool. And finally, the last point on our journey is I just want to talk a little bit about tooling, especially for Ruby. Useful tools. So Jupyter Notebook, which is used like by most data scientists across industry and for a lot of machine learning. You can actually use Ruby in Jupyter Notebook, which is something that might not be obvious. There's iRuby, which is a Jupyter Notebook kernel that allow you to run Ruby. And then you can also obviously load your Rails app into Jupyter Notebook. So you could like pull your data using Active Record right in your notebook and then do analysis inside your notebook just using Active Record. The second tools is data frame. So for people who are familiar with Python and data science, there's pandas, which are really popular. So that's kind of an equivalent in Ruby that is pretty good, called Daru. And then finally, the third tool is more resource, but obviously to do that, like prompt engineering is really important. And there's a lot of different like prompt engineering tricks that are, I mean, once you know them, it's fairly straightforward. But prompting guide.ai is a really great guide that like document all those different tricks. So if you're going down the route of LLMs, I would definitely recommend looking at this. Cool. That's it. Thank you. And finally, I'm going to do my shameless salesman plug. I hope no one is a car salesman there, then you're not offended by my stereotype. But yeah, Circle Medical, we're hiring aggressively in 2024, so we're planning to double the size of our engineering team. And for all sorts of positions, some may or may not be on our website yet. So feel free to go on our website or reach out to me directly, JS@Circle Medical.
Last questions.
Of course, question time.
I have big questions, but
Yeah.
it's a lot of make it short. Is it HIPAA compliant, having like an AI scribe